This question has graphs in it. So the first thing we want to do before we even read the question is to do some analysis of the graphs. And we do that with an Oizerga, the origin. Again, the origin is to determine if we're in quadrant 1, 2, 3, 4, and whereabouts we are, and it appears that we are located right there. Y-axis is speed for all of them. The x-axis is time for all of them. The intercepts are varied for each one, but it gives us the speed at the outset. The things we can read are the axes themselves, velocity and time. The slope is dividing those, delta v over delta t, which is the rate of change of velocity is the definition of acceleration. And the area v times t has units of meters per second times seconds meters, or it's the distance. But now we'll look at the question. The relationship between a freely falling object and the time of fall. Well, if an object is falling freely, it doesn't tell us it starts at rest, but if it's falling freely, the speed should increase. So the first one shows speed at a constant rate. Second one shows increase in speed. Third one shows a decrease in speed. So just knowing that it will get faster as an object falls gets us to 50-50. Now the difference between these two is that this one has a constant slope. Number 4 has a constant slope. And choice 3 has an increasing slope. And the slope is the acceleration. So this is increasing acceleration, and the constant slope means constant acceleration. Well, the acceleration caused by gravity is 10 meters per second squared, and that's basically constant near the surface of the Earth. That's why choice 4 is the best answer. And for those who might say, like, well, if something is really high, the acceleration will change. It will get higher when you get closer. And that's true. And that's why the question stipulates it's near the Earth's surface. And you remember from the examples we looked at in class that we did that is something, humans from an airplane to the bottom of the Marianas Trench, the G doesn't even vary at all. It stays at 9.8. It might go down to 9.78 and 9.87, like that, but it's 9.78, 9.8, 9.87. It might vary like that, but it still remains 9.8 meters per second, or 9.81, something like that. And that distance is so small that it wouldn't even show up on the scale of this drawing. So again, if it's near the surface of the Earth, G changes so little, so the acceleration will be constant, and that's choice 4.